Hello everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the 7th part. In this part, we're supposed to determine the standard equation of an ellipse. We sketch the graph of that ellipse given the endpoints of the minor axis and the endpoints of the major axis. Before we go over this example right here, let's have a review on the parts of every ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the A will be under the X. Now, we also remember that the value for A is always greater than B. And the equation that relates A, B, and C is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is H comma K plus minus C. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, going back to the problem right here, we are given the two endpoints of the minor axis. We remember that the endpoints of the minor axis are actually the co-vertices, while the endpoints of the major axis are actually the two vertices. So I'm going to go ahead and write that down here. So let's sketch or plot the four dots here and label them as the co-vertex and the vertex. Okay, now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So in this case right here, we are supposed to determine the midpoint between either the two co-vertices or the midpoint between the two vertices. Looking at this, we can go ahead and say that the midpoint is located right here, or this is the center, so that we can go ahead and say that our center is actually located at negative 1, 5, and this is an example of a horizontal ellipse because the two vertices are horizontal relative to each other. So I'm going to go ahead and write that information up here. Since this problem is an example of a horizontal ellipse, our a squared will be under the x squared. So this is the general equation for horizontal ellipse. Now looking at this, we remember that the distance from the center to the vertex is represented as letter A. So in this problem right here, we can go ahead and say that our A is, we can use the distance formula to determine the distance between these two, or we can go ahead and count it. 1, 2, 3, 4, 5, 6, 7. So that's plus minus 7. This tells us that our a squared is 49. And we also have the b value. We remember that the distance from the center to the co-vertex is letter b. And so I go ahead and count it. Our b then is plus minus 1, 2, 3, 4. And so our b squared is 16. So we're going to use the values for a squared, b squared. Our center is again represented as hk. We plug it in here so the equation will come out. X, that's gonna be our h is negative 1. So remember we switch and switch. So that is x plus 1 because we switch it squared over. Our a squared is 49 plus we have a y. And then that is a positive 5, so that would be a minus 5, because remember we switch over. Our b squared is 16, and that is equal to 1. So this is the equation that would work for this problem that we have up there. Now we are supposed to sketch the graph of this ellipse. Now we are supposed to determine the location of the two foci. We remember that the focus of an ellipse is c distance from the center. So we don't know what it is. It should be somewhere around here. But the distance from the center to the focus is letter c. And so we can solve for c using the equation c squared equals a squared minus b squared. So I'm going to go ahead and write that equation up here. So we now have to solve for c. So c squared is equal to our a squared is 49, and then our b squared is 16. So 49 minus 16 is 33. And so our c, because we're going to solve only for c, so we're going to square root both sides. So that would be a plus minus square root of 33, or this is approximately 5.74. So I go 5.74 left and 5.74 steps right. So 1, 2, 3, 4, 5.74 should be somewhere around here. That's the first focus. 1, 2, 3, 4, 5.74. And so this is the other focus right here. So that we can go ahead and write the coordinates of the two foci. Now, since this is an example of a horizontal ellipse, we remember that the focus for horizontal ellipse is h plus c comma k and h minus c comma k. So in this case right here, I am going to write the h, since it's horizontal, I'm going to add the square root of 33 to the h here, so that this would come out negative 1 plus square root of 33, and then the k is 5, and the other coordinate is gonna be negative 1 minus square root of 33, and then comma 5. These are the coordinates of the two foci. So if you notice, we actually have the same HK value for the coordinate of the foci. That's negative 1, 5 and negative 1, 5. But we just had to add and subtract the value for C. That's how I got the plus 33, square root of 33, and then minus square root of 33. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we remember that the endpoints of the minor axis are actually the co-vertices, while the endpoints of the major axis are actually the coordinates of the vertices. So I'm gonna go ahead and label that up here. So let's sketch or plot these 4 points here and label them as either co-vertex or a vertex. Okay, now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So looking at this, our midpoint or our center is located here. So this is our center. And the coordinate for this center then is 4, 0. And since these two vertices are vertical relative to each other, we can go ahead and say that this is an example of a vertical ellipse. I'm going to go ahead and write that information up here. So I have written here the general equation of a vertical ellipse. Notice that our a squared is under the y squared. Now we remember that the distance from the center to the vertex is our a. So looking at this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our a value is plus minus 9. This tells us that our a squared then is 81. And our b is actually the distance from the center to one of the two co-vertices, and that would be 1, 2, 3, 4, 5. So this is a plus minus 5. This tells us that our a squared is 25. So we are going to plug the values of h, k, a, and b. Remember, our hk is the center, hk, and we already have the a squared and the b squared here. So then we can go ahead and say that our equation will come out. This will be x switch. So that would be x minus 4 squared over the b squared is 25 plus our k here is 0, so y minus 0, it doesn't really matter. So we can just go ahead and write that as y, because the subtracting 0 from y doesn't really change it. So y squared over our a squared is 81 is equal to 1. So this is the equation of this word problem that we have up there. Now we are going to sketch the ellipse. So we're going to determine the location of the focus. Now we remember that the focus is c distance from the center. So it should be located somewhere around here. So that is a distance of c. So we're going to solve for c using the equation c squared equals a squared minus b squared. I'm going to show the work down here. So our value for C is 7.48. So what I would do is I will count 7.48 up, 7.48 down, and locate the two foci. Okay, we can therefore write the coordinates of the two foci. Since this is a vertical ellipse, we remember that the coordinates of the two foci would be h comma k plus c and h comma k minus c. So what I would do here is, since this is vertical, I write 4 and then comma, that's the h, and then that's a 0 for the k, so 0 plus our c is 2 square root of 14. So that is 2 square root of 14. So this comes out 4 2 square root of 14. Because if you add the 0 and the 2 square root of 14, it's just 2 square root of 14. And then the other coordinate would be 4 0 minus 2 square root of 14. And so this gives us 4 negative 2 square root of 14. So these are the coordinates of the two foci. 4, 2 square root of 14, and 4, negative 2 square root of 14. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!